All right, guys. So last class we talked about central angles and inscribed angles, right? Central angles, again, they have the vertex as the center of the circle, right? And we found that if I have a central angle of, here in this case, my angle is called ACB, it is going to be the same thing as the related arc. So I know that angle ACB is equal to the arc AB. So again, if we had an example, let's say that this angle of ACB is equal to 20 degrees, that means that the arc is equal to 20 degrees, right? Central angles are the same thing. The same thing, okay? This is not on your notes. I just wanted to go ahead and give a little recap, okay? Inscribed angles are a little bit different. So here we have the inscribed angle of ABD, right? And the related arc of AD. So here's arc AD. Okay, there are two ways to go about these guys. If I were to go ahead and start with my angle measurement of 15 degrees, so let's go ahead and say that we are going to go ahead and find the arc. All I would have to do is take my 15 degrees, my angle, and multiply it by 2. So my arc AD would equal to 30 degrees, right? Vice versa, if I were to go and start with my arc measurement, let's say that arc AD was 30 degrees. To find the missing angle, I have to go ahead and take the arc measurement of 30 and divide it by 2, which would give me 15 degrees. So you're either multiplying or dividing by 2 if you have an inscribed angle. Okay, so let's go ahead and go to your notes. So we are on page 14. We're going to do page 14 and 15. Our goal today is to describe arcs and angles using our algebra. Okay, so remember the inscribed angles is half the measurement of the related arc. That is exactly what we just talked about. Okay, so let's go ahead and start with example 1. It says to go ahead and use circle N. When I'm saying you use circle N, right, your center point is just N. Okay, so our job is to find the measurement of JKL. So here's JKL, right? And you guys can use your highlighters. There's JKL. Now JKL has the related arc measurement of arc JML. So my first step is I have to go ahead and find the major arc JML, right? And going back to circles, what do we know circles measure up to? They measure up to 360 degrees. So if I know that arc KJ is 53 and I know that arc KL is 65, all I have to do is take 360 and I'm going to subtract those two. So I'm going to take 360 minus 53 minus 65. And let's go ahead and plug that into the calculator. 360 minus 53 minus 65. That gives me a value of 242. So that means my big major arc is 242. And I have to find my missing angle. So again, if I start with the arc and I'm finding the angle, I have to take my arc and I divide it by 2. That makes sense because if I'm looking at this arc, this is a huge arc, guys, and this is kind of a very, not a very small angle, but this angle is obviously smaller than the arc. So it would not make sense to take 242 to multiply it by 2, right? I have to go and cut this guy in half to find my related angle. So let's go and find it. We are going to go and find the measurement of JKL, and I'm going to take the 242 and divide it by 2. So I'm going to take 242 divided by 2. That gives me an angle measurement of 121. So that means my angle measurement of JKL is equal to 121 degrees. Okay. Example 2. I'm going to go ahead and take my colors and start highlighting. So I'm going to highlight angle RST. Here's angle RST. And I'm going to take my second color. I'm going to highlight the measurement of angle RUT. And what do we notice about these two angles? What arc do they have in common? We see that they both share arc RT. Whoop whoop. Okay, so same exact process. I know that a full circle is equal to 360 degrees. So to get this small angle, this minor angle of RT, I have to get rid of the 64, the 139, and the 75, right? So my first step is I'm going to go ahead and find the measurement of arc RT. And again, I'm going to take 360. I'm going to go ahead, let's do minus 360 minus the 64 minus the 139 minus the 75. So let's go ahead and do that. I'm going to do 360 minus 64 minus 139 minus the 75. And therefore I get 82 degrees. So that means arc RT is equal to 82 degrees. So we have to find these smaller angles of RST and RUT. So again, if we start with the arc, I have to go ahead and find the angle. So I'm going to go ahead and divide by 2. Right? So my second step, let's go ahead and find angle RST. I'm going to take the 82 degrees and I'm going to divide by 2. So I take 82 divided by 2. That gives me an angle measurement of 41 degrees. So if this angle is 41 degrees, and if they share the same arc, right off the bat, guys, I could just say that RUT is also 41 degrees because they share the same arc. Ta-da! Okay. All right, number 3 is when we're actually going to go ahead and start the algebra part. Okay, so it says use circle P to find X. So I'm going to go ahead and first I'm going to go ahead and highlight my angle. So there's my angle. I know that angle LMN is equal to 67 degrees, right? I have to find the related arc of all LN. So my first job, I have to go and find arc LN. And if we are finding the arc measurement, I have to go and take my angle and multiply it by 2. So I'm going to go back. I'm going to look my angle. It looks like we have 67. I'm going to multiply that guy by 2. So on my calculator, I'm going to type in 67 times 2. And that gives me a value of 134. That means my arc is equal to 134. But wait, right? It told us off the bat that 4x plus 58 is equal to the arc LN. But I just found out that LN is equal to 134. What? How could that be, right? We can go ahead and set up an equation. We have to solve for x, right? So I know that the arc LN is equal to 4x plus the 58, but it's also equal to the 134. And then from there, I can go ahead and solve for x, right? Let's go and solve for x. I'm going to go and subtract 58 on both sides. So I get 4x is equal to, I'm going to type in 134 minus 58. That gives me a value of 76. Last but not least, guys, I have to go and divide both sides by 4. So we get x is equal to 76 divided by 4. X is equal to 19. Done. We did it. We can also check our answer though. If I think my math is a little bit dicey, right, I can go and check it. I can plug in x for 19, add the 58, right, and I can plug this into my calculator. So I can go and plug in 4 times 19 plus the 58. That gives me 134, which is what we found out to be the arc measurement. So all is well. Okay, let's go and do example 4. Very similar, right? This time I know that arc CE is equal to 158. I have to find its related angle. So I have to go ahead and find the measurement of angle CDE. And again, if we start with the arc and I'm finding the smaller angle, I have to go and divide by 2. So I'm going to take 158 and I'm going to divide by 2. If I go plug that into my calculator, 158 divided by 2, that gives me a value of 79 degrees. So that means this angle is 79 degrees. From there, I can go and set up my equation. I know that the angle is equal to 79 degrees, but it's also equal to the 8x minus 9. So I can go ahead and solve for x. I'm going to add 9 on both sides. 79 plus 9, what's that? That's 88 is equal to 8x, right? I'm going to go and divide both sides by 8. So I get x is equal to 11. Dunzos, we did it, yay! All right, I'm going to go and press pause from there.